Hello, good afternoon, everyone. I am Genevieve Rubin, and this is the continuation of our report. So, I know that some of my topic, so I know that I cannot explain properly, but I apologize for that, and I hope that some of you can share their ideas or thought about this topic. So, thank you in advance, and let us proceed to the normal distribution. So, a special kind of asymmetrical distribution that is most frequently used to compare scores. So, ito madalas yung ginagamit na para makapag-compare ng scores ng ating mga students. So, these are drawn as a smooth curve, one curve standouts, which is the bell-shaped curve. So, para siyang bell. So, it is also called a Gaussian distribution, named after Carl Friedrich Gauss. So the standard deviation is used to determine the percentage of the scores that fall within a certain number of standard deviations from the mean. So ito, ginagamit din to, no? To determine whether our students scores is above the average or below the average. And also, para ma-determine din natin yung performance ng ating mga students. So, ito po ang kanyang um, sample ng ating normal chord. So, in assessment, the area in the curve refers to the number of scores that fall within a specific standard deviation from the mean score. So, in other words, each portion under the curve contains a fixed percentage of cases as follows. So, 68% of the scores fall between one standard deviations below and above the mean. The 95% of the scores fall between two standard deviations below and above the mean. The 99.77% of the scores fall between three standards deviations below and above the mean. So, ito po ang kanyang sample. So, it shows the areas under the normal curve. So, wala po kasi ako makitang ibang photos. So, kinrap ko na lang po ang features. So, from this figure, we can state that the properties of the normal distribution. So, number one, the mean, median, and the mode are all equal. So, equal po ang silang tatlo. The curve is symmetrical as such as the value is in a specific area on the left is equal to the value of its corresponding area on the right. So, when we say the symmetrical, no, the both sides are the same. So, the curve changes from the concave to convex and approaches the x-axis but the tails do not touch the horizontal axis. So, dito, so when we say concave to convex, yung concave means it was rounded inward. So, while the convex is rounded outward. So, and for the total area of the curve is equal to 1. What are standard scores? So, according to the study.com, standard scores is a set of scores that have the same mean and standard deviation. So, they can be compared. No? So, sabi doon, um, so this allows for easy comparison of scores across different tests or assessments as they all have the same statistical properties. By converting raw scores to standard scores, we can see how far above or below the average student's performance is regardless or the specific test or scale used. So this can be a particularly useful when comparing students' performance across multiple subjects or over time, as it allows us to identify areas where students may be um, consistently strong or weak. So rather than relying on raw scores that may vary widely from tests, um, may vary widely from test to test. Sabi doon. So the most useful is the z-score, which is often used to express a raw score in relation to the mean and the standard deviation. So meron tayong example ng formula. So this relationship is expressed in the following formula. So ito po ang kanyang sample. So recall that the raw score minus the mean is the deviation score. So um, z is the z-score is equals to x, which is your score or the raw score of students, minus the mean divided by the standard deviation. So with these differences, we are able to know whether your test scores say that the x is above or below the average score. So the standard deviation helps you locate the relative position of the score in a distribution. So a z-score is called a standard score simply because it is deviation score expressed in the standard deviation units. So if raw score are expressed as z-scores, so we can see their relative position in their respective distribution. Moreover, if the raw score are already converted into standard scores, we can now compare the two scores even when the scores come from different distribution or when scores are measuring two different things. So ito po ang uh, kanyang sample. So it shows a comparison of score distribution with different means and the standard deviation. So in the figure na nakita nyo po kanina, a score of 86 in English indicates better performance than a score of 90 in P6. So let us suppose that the standard deviation in English and P6 are 3 and 2. So yung English, ang standard deviation niya is 3 and ang P6 naman is 2. So ito po ang kanyang formula. So uh, z-score in English is equal to 86 minus 80 divided by 3 is equals to 2. And sa physics naman po is 90 minus 95 divided by 2 is equals to negative 2.5. So pansin nyo po na mas mataas yung nakuha ng English kesa sa physics. So from the above, if 86 and 90 are your scores in two subjects, you can confidently say that compared with the rest of your class, you perform better in English than physics. So that's because in English, your performance is two standard deviations above the mean. So while 90 is numerically higher, so this course is more than half standards deviation below the average performance of the class where you belong, while 86 is above the mean and even two standards deviation is above. So as you can see sa C-scores, mababa yung binibigay niyang um, total. So, so this figure or this is shown the different row scores in a 1 z-scores distribution. So, yun nga, as you can see, yung P6 is dito siya naka-line up sa negative side and yung English naman is sa positive side. So, note that the figure 8.8, the shaded area in two graphs indicate the proportion of scores below yours. So this is the same as saying that is proportion in the number of students in your class who scored lower than you. Examining the area under the normal curve, so we can say that about the 98% in your class scored below you in English, while the 1.2% scored below you in P6. So we assume here that the scores are normally distributed. So T-score. So as you can see in the computation of C-score, it can give you a negative number. Yan, as I said earlier, mababa lang yung number na nabibigay ni Z-score, which simply means that the score is below the mean. However, the communicating negative Z-score as below as the mean may not be understandable to others. So one option is to convert a z-score into a t-score. So from negative, i-convert naman natin siya into a positive. So which is the transform standard score. So there is a scaling in which a mean of 0 in a z-score is transformed into a mean of 50. So in the standard deviation in the z-score is multiplied by 10. The corresponding equation is t-score is equals to 50 plus 10 z-score. So, for example, a z-score of negative 2 is equivalent to t-score of 30. So, ito siya. T-score is equals to 50 plus 10 times negative 2 is equals to 50 minus 20. The total is 30. So, looking back at the English course of 86, which resulted in a z-scores of 2 as shown in the figure 8.7, no? T-score equivalent is T-score is equals to 50 plus 10 times 2 is equals to 50 plus 20. So, 10 times 2 is 20. Kaya 50 plus 20 is equals to 70. Stay 9 scores. Another standard score is a stay 9, shortened from the standard 9. So with 9 in its name, the scores are on the 9-point scale. So in a z-score distribution, the mean is 0 and the standard deviation is 1. So in this scale, the mean is 5 and the standard deviation is 2. Each stay 9 is 1/2 standard deviation wide. And like the t-score, a staining score can be calculated from the z-score by multiplying the score by 2 and adding 5. So for example, stay 9 negative 2 times 2 plus 5 equals 9. So going back to our example on the score of 86 in English, that is equivalent to a z-score of 2. Its staining equivalent is stay 9. 2 times 2 is equals to 4 plus 5 is equals to 9. So example scores in the staining scales have some limitation since they are in 9-point scale and expressed as a whole number. They are not precise. So on the assumption that staining scores are normally distributed, percentages of cases in each band or range of scores in the scale as follows. So, ito po. Yung staining score and the percentage of scores. So, the lowest is 4%, next low 7%, next low 12%, next low 7%. And yung middle niya is nasa 20%. So, the next high is 17%, next high 12%, next high is 7%, and the highest is 4%. So with the above percentage distribution of scores in each stay 9, you can directly convert a set of row scores into staining scores. Simply arrange the row scores from the highest to lowest. So ito po siya. And when the percentage of scores in each stay 9, you can directly assign the appropriate staining score in each row score. So these figures show the normal distribution and the standard score. So hindi lang siya masyadong clear, no? Pero sa book po, clear po yan siya. What are the measure of covariability? Measures of covariability tells us to a certain extent the relationship between two tests or two factors. A score one gets may not only be due to a single factor but with other factors directly or indirectly observable, which are also related to one another. And this section will be limited to introducing two scores that are hypotheses to be related to one another. So, correlation between two variables in finding the degree of relationship between two scores. So I know that some of you know this topic. The statistical measure is the correlation coefficient, and the index ranges from negative 1.0 to positive 1.0. The value of negative 1.0 indicates the negative perfect correlation, and the 0.00 means it is no correlation at all, and the 1.0 means perfect positive correlation. So correlation coefficient did not result in an exact values of 0.0, 1.0, and negative 1.0. Instead, the correlation values are either closer to 1.0 or um, negative 1.0. So the various types of relationships are illustrated in the following scatter plot diagrams. So it shows the various types of relationships. Ayan po siya. So yung set A, shows the perfect positive correlation, and yung set B is the perfect negative correlation, and the set C is show that no correlation at all. Some example of interpreting correlation coefficients are as follows. So ito po siya. So coefficient niya R is equals to negative 0.90, direction negative, strength strong. Is equal to 85, direction positive, strength strong. R is equals to 68, direction positive, strength moderate. R is equals to negative 30, direction negative, and the strength is weak. And lastly, R is equals to 0.05, direction is positive, and the strength is very weak or negligible. So the further analysis, the correlation between two scores, a statistical test to determine the correlation coefficient of two variables is needed. So in actual practice, we deal that the test scores so that the data set is an interval and ratio level measurements. Hence, the commonly used statistical analysis is the Pearson product moment correlation. So different versions of Pearson product moment correlation. So number one, a deviation score of formula, where R is equal to correlation coefficient, X is equal to the raw score in a variable X. um, the other one is X var or X variable is equals to mean score in the first variable, Y is equals to raw score in the second variable, and the Y variable mean the score in the second variable. So note that in the summation of xy, x and y are deviation score from the mean score in the first variable and the mean score in the second variable respectively. The raw score formula is very easy because a simple scientific calculator can provide the values for summation of x squared, summation of y, and summation of y squared. So this formula has been introduced earlier in lesson 6 when you were taught on how to compute the reliability coefficient of scores. So this is the same Pearson R, but this time it is used to establish relationship between two sets of data. So it shows the computation for correlation for the raw score data. So that the n summation of xy minus summation of x times summation of y over the square root of and quantity summation of x squared minus quantity summation of x squared times the square root of quantity summation of y squared minus the quantity summation of y squared. So the above mathematical process gave a correlation coefficient of 0.705 between the performance scores in reading and problem solving. So this coefficient indicates the moderate correlation between performance in reading and the problem solving. Ito po yun siya, yung sample dito kanina. Wala na. So precautions to be observed with regard to the computed R as correlation coefficient. So it should not be interpreted as percent. Thus, the 0.705 should not be interpreted as 70%. So if you want to extend the meaning of 0.705, then compute for R2, which becomes the coefficient of determination. So this coefficient explains the percentage of the variance in one variable that is associated with the other variable. So with the reference of the two variables indicated in table 8.3 and the computed R of 0.70 rounded off the nearest hundreds, so it results to an R2 of 0.49, which can be taken as 49%. This can be interpreted as 49% of the variance in the problem-solving test, scored and associated with the reading scores. Thus, R2 helps explain the variance observed in the problem score. The total variance is equals to 1. In percent, 100%. If 49% of the variance observed in the problem-solving scores was attributable to reading scores, then the other 51% of the variance in the problem-solving test scores is due to the other factors. So this concept is concretized in figure 8.12. So while the correlation coefficient shows the relationship between two variables, it should not be interpreted as causation. Considering our example, we could not say that the scores in reading test causes 49% of the variance of the problem-solving test scores. Relationship different from causation. So this show the covariation of performance in reading and problem solving. So I think some of you know about this topic or have an idea about this topic, so you can share it to others po. That's the end of our report, so thank you po and God bless.